for your project too, you have to write some pretty scary assembly program. So and you will have to use a stack too. So today we're gonna talk about how to use a stack to help you write assembly programs. So uh in your project one, I think you also write either I mean it's not recursive, but just a regular assembly program. And you may think at that time that you realize you have to fit every register every variable you use into a register. But when we're working with stack and this some register you cannot use because they we have to use function calls, there's gonna be the return address and or like the some register is gonna hold the stack pointer, stuff like that. So you for the project two, you're gonna have less register to use. And you might find yourself leaving with just two register. But you say, okay, two register, I can do all the add and the subtracting and stuff. But is it really though? So if it's like this, then you can say, okay, put seven into register one, put two into register two. And you say, okay, register one equal to register one minus register two. Well, and then you now you give register two three, and you do the register one thing again. Um, but so you can see this works if you just have two registers, but that's not always the case. And what if it's like this? Because the parameters limit us, we have to get this first, and then get this before we can add. So let's try to do the same thing. So R1 is equal to 7, R2 is equal to 2, R1 is equal to R1 minus R2. Well, you notice that I'm not writing assembly, but you should be able to convert this to assembly quickly. You can see that now we have a problem because I don't know what this is. And I cannot just say, oh, it's equal to something, maybe, well, it's R1 plus whatever result of this is. I haven't computed it, so we have to use a stack in this case. Um, so after we're done with this part, we probably want to push this into the stack so we can use it later. So I'm drawing a stack here. So uh, again, not writing assembly here, but I'm going to talk about how to convert it to assembly later. So now we have this here. We can erase a result. We can reuse register one, so we can compute the second one. Uh, Now that we have this ready, you can see that now R1 is holding this part, but R2 we can overwrite. So we can pop into R2, and now we just compute R1 equal to R1 plus R2. And you can see now the R1 now holds the correct result. Well, uh, it's a little complicated if you actually want it to be assembly because many of push and pull pop actually translate into one potentially two or more instructions, at least two. So what you need to do here in assembly is you have to store R1 at stack pointer. And after that, well, you have to modify the stack pointer so the next guy can use it properly. Otherwise, if you don't change the stack pointer, you will keep storing into the same location. So you probably want to say stack pointer, which ideally is going to be on one of your registers because you're going to have a lot more instructions if you keep loading this one again and again. And bigger problem is you cannot find it. So I think the stack grow bigger or smaller. I mean, you should read the spec. You should say some. You should clarify about this. And pop, it is going to be the opposite. So um, load R2 now this case equal to man stack pointer, and you should do the opposite operation you did last time. And that's about it.